Hi, my name is Catherine Bitterick, and I'm an early childhood education major at UC Blue Ash, and I'm doing section 6.2 developmental processes. So, a widespread myth about the brain is that it does all of its maturing within the first few years of life. It actually continues to develop throughout childhood, adolescence, and adulthood, especially the prefrontal cortex. And this is the area in the red. It's responsible for planning, decision-making, and advanced other reasoning processes. It's especially slow to mature, and it doesn't take on a truly adult-like form until individuals are in their early 20s. Two types of brain cells are neurons and astrocytes. Some parts of the brain continue to form new ones throughout a person's lifetime, especially astrocytes. And here's the anatomy of a neuron. This right here is the soma, or the cell body. It contains the nucleus and is responsible for general well-being. Here is the dendrites. Here are the dendrites. They're like the branch-like structures. They receive messages from other neurons. And the axon right here is the long arm-like structure that transmits info to other neurons. And they form interconnections called synapses that don't actually touch. Synapses are tiny spaces across where chemical messages are sent. So right here, this little area is the synapse, and this in the purple would be the axon, and it sends the chemical information. And the synapse right here is the area where they don't touch but connect, and the dendrite receives information. And then synaptogenesis is the process of forming synapses, and it occurs before birth. It dramatically increases after birth. Children in elementary grades have more synapses than adults do, but it's not necessarily better because it makes it harder for them to adapt to certain situations and provides inconsistent behavior patterns, and it decreases brain efficiency. Synaptic pruning. In general, pruning means to cut away. So in planting, you would cut the bad branches off in order to make room for new ones to form. And this increases the plant's fruitfulness and growth, and it makes it more effective. And it also happens in the brain. This is called synaptic pruning. Decreased use of synapses leads to them fading away. Increased use of synapses leads to them staying and strengthening. Synaptic pruning is seen in this picture right here. At birth, there are some synapses. At 6 years old, so like elementary age, there's a lot of synapses. And then at 14 years old, there are less synapses, but they're stronger. And this is because pruning has occurred, and it refines and makes the brain more effective. So pruning increases brain efficiency. And then myelination. So that's the formation of myelin, which is like a fatty white coating on the axon, and it's this bubble-like structure right here on the axon. So it basically it helps signals transmit faster, so information can come quicker. And it continues into early adulthood, especially in areas of the brain that are heavily involved in thinking and learning. There isn't a best time to learn, and this is because the brain has plasticity, and this increases the brain's ability to adapt itself to changing circumstances. It persists throughout the lifetime. Jean Piaget, a Swiss psychologist, had the theory of cognitive development. He believed that the things children learn and do are organized as schemes. Schemes are groups of similar actions or thoughts that are repeatedly used in response to the environment. So initially based on sensory and behavioral responses to objects. For example, it could be an infant putting things in their mouth, and this would be a scheme that he applies to all objects. This is how infants explore and find out about the world, through sensory and behavioral responses. Children have a natural curiosity about their world. They actively seek out information to help make sense of it. Piaget believed that children's curiosity is a desire to adapt to and be successful in their environment. Such adaptation occurs through two complementary processes. One of them is known as assimilation. This is responding to new info and interpreting it in a way that's consistent with an existing scheme. So for example, a child and their parent are taking a walk and the child sees a dog, and he knows it's a dog because it has 4 legs, he can pet it, it barks, it wags its tail, it can walk and it has hair, and the adult's like, yes, that is a dog. And he sees another dog and he applies that new information to his dog scheme. So he knows it's a dog because it has 4 legs, he can pet it, it barks, wags tail, can walk, and it has hair. So yeah, and then accommodation is the second process, and you can't easily relate to a new object or event using existing schemes. Children either modify their existing scheme or form a new one. So in this situation, the child sees this raccoon, but he doesn't know what a raccoon is, so he's like, oh, a dog. Can I pet it? So he goes over to pet it, but the adult's like, no, don't pet it, that's a raccoon. But he thought it was a dog at first because it had 4 legs, it has hair, and it can walk. And the adult's like, no, that's a raccoon. So he knows a raccoon hisses, snarls, is dangerous, likes trash, and you don't want to pet it. So he's accommodating this new information into his raccoon scheme. And yeah. So I watched a video on Khan Academy about assimilation and accommodation. And assimilation has 2 S's for same scheme, and accommodation has 2 C's for change and create a new scheme. So you have your same scheme in this situation, but you're creating a new one in this one. And development builds on prior acquisitions. So virtually all aspects of child development involves a continual process of refining, building on, and occasionally reconfiguring abilities and achievements. Observations of the physical environment and frequent interactions with it promote development. According to Piaget, active experimentation with the physical world is essential for cognitive development. So in ECE, we're taught that hands-on learning is better than worksheets, and children like to explore and manipulate objects to obtain knowledge. They learn best this way. Language development facilitates cognitive development. So Piaget believed that language provides a set of entities or symbols through which humans can mentally represent external events and internal schemas. And Vygotsky believed that thought and language are separate until about age 2, when they're intertwined with when children express their thoughts when they speak and begin to think in words. So Vygotsky, a Russian psychologist, he believed that when thoughts and language first merge, children often talk to themselves. This is called self-talk. It's important in cognitive development. Through self-talk, children learn to guide and direct their own behaviors through difficult tasks. Self-talk evolves into inner speech. This is where children talk to themselves mentally instead of aloud. And they continue to self-direct, but you can't see or hear them do it. And interactions with other people promotes development. So Piaget and Vygotsky both believe that social interaction is critical for cognitive development. Language is good because it enables children to exchange ideas with adults and peers. It helps children to realize that other people see things differently than they themselves do. They also see that their own perspectives may not be accurate or logical. For example, a child believes that all deserts are hot, but he learns in class from his teacher that deserts can be cold too. For example, some can be cold at night but hot in the day, or Antarctica is cold all the time and it's a desert. So he's taking this new information from language and modifying his perspective so it's more accurate and logical. And then Vygotsky, he believed in mediated learning experiences. So as adults interact with children, they often share the general meanings and interpretations they attach to objects, events, and human experience in general. Cognitive tools, so adults also share concepts, procedures, and strategies that enable children to deal effectively with complex tasks and problems. And he also believes in internalization. So this is a process in which a learner gradually incorporates socially based activities into his or her internal cognitive processes. and people have their own unique ideas when it comes to internalization, and an example is self-talk to inner speech. Mental processes also evolve as children interact with others. And inconsistencies between existing knowledge and new events promote development. Children are naturally inclined to make sense of their environment. In equilibrium, they're able to address new events with existing schemes, and in disequilibrium, they're not able to address new events with existing schemes. Equilibration occurs when equilibrium leads to disequilibrium, and this leads back to equilibrium. Children want to achieve equilibrium, and this leads to increased levels of thought and knowledge. Children have difficulty with class inclusion, so this is thinking of an object as simultaneously belonging to two categories. So an example in the textbook was that they had wooden beads. So a person was asking a child about wooden beads. The child was 6, and he asked, "How many wooden beads are there?" And the child said 7. And he was like, "How many yellow beads are there?" And the child said 5. And he asked, "Are there more wooden beads or are there more yellow beads?" And the child said, "There's more yellow beads, but there's actually more wooden beads. He just can't do class inclusion yet." So challenging tasks promote development. Children can typically do more difficult things in collaboration with adults and other more advanced individuals than they can do on their own. So Vygotsky, his idea was the zone of proximal development. And this is where learning occurs. In one of my classes, I learned that it looks like a ladder. So basically, the child is here at the independent level, and they can't learn at this level because they've already mastered the information, and they can do things on their own. But with scaffolding, which is like help from a teacher, an adult, or someone more experienced, they can learn at this level. This is where learning occurs, the instructional level, which is also known as the ZPD, the zone of proximal development, and the frustration level. That's where the child can't learn, even with help, and this is known as an impossible task. Children develop very little from repeating tasks they already do independently. Each zone of proximal development is different. Some children can stretch their abilities, while others may be able to only handle a little bit more difficult tasks. Children develop primarily from taking on challenges that require support, tasks within their zone of proximal development. And this is my works cited. So that concludes my presentation of section 6.2, developmental processes, and thank you for watching.